So the question reads as, the vapor pressure of water at 20 degrees Celsius is 17.5. What is the vapor pressure of water over a solution prepared from 2.00 times 10 to the second grams of sucrose and 3.50 times 10 to the second grams of water? So the equation is asking for vapor pressure. So what is the formula for vapor pressure? So vapor pressure is equal to the mole fraction times the vapor pressure of the pure solvent. So first, I want to start tackling the mole fraction. Mole fraction is basically going to be the moles of whatever you are trying to figure out. So in this case, the moles of water over the total moles of the solution. So first we need to figure out what the moles of both their components in this solution are. So what are the moles of sucrose and what are the moles of water? So let's first take our first value. So 200 grams of sucrose, which is the exact same thing as 2.00 times 10 to the second. So 200 grams of sucrose, and then you're going to multiply that by its molar mass to get you your mole value. So the molar mass of sucrose is 342.3 grams. And you can just find this again. It gives you the formula, the formula of sucrose. So you can say, okay, I have 12 carbons, 22 hydrogens, 11 oxygens. Find their values, multiply them, get this value here. But everyone should be able to know how to do this at this point if you are already at the point of calculating vapor pressure. Okay, anyway, so then we're going to now find, and when you multiply this value, you are going to get 0.58 moles of sucrose. And now let's find how many moles of water we have. So again, 350 grams of water. You want to find the mole value, so you multiply it by its molar mass, which is 18 grams per mole. I think it'd be really easy to just remember that value because a lot of times you're going to need to know the molar mass of water, so having that value by memory is pretty helpful. And then you multiply that together and you're going to get a mole value of 19.4 moles of water. So basically, okay, we have the mole values. What would be our total mole value? So the whole solution has how many moles? So if you add these two values together, you get a total of 19.98 moles of solution. So why I do this is because you're going to need that to help calculate your mole fraction. Because again, your mole fraction is going to be equal over to the moles of your solvent, or in this case, the moles of water, which is what they're asking for. They're asking what is the vapor pressure of water. So we say moles of water is 19.4, and we want to see what is the fraction of water out of the total moles. So then you'll take the total mole value and you'll put that on your denominator. And then you're going to get a mole fraction value of 0.971. So now you have this value here, which goes in this part of the equation. So the last thing we need is the vapor pressure of the pure solvent, which they actually give you in the equation. It states it right here. The vapor pressure of water at 20 degrees Celsius is 17.5. So they give you that value right there. So you just plug it in. So the vapor pressure is equal to your mole fraction, which we've calculated 0.971, times the vapor pressure of the pure solvent, which they gave you as 17.5. And basically just put it in your calculator and you will get a value of 16.99, or you can just round that to 17. And that is the vapor pressure of water over the solution. As you can see also, just kind of a note, sometimes in problems they're going to give you values that you don't necessarily need to use. In the case that we didn't need to use 20 degrees Celsius, the value of 20 degrees Celsius anywhere in our equation. So be aware that you're not always going to use every single value or temperature or whatever is given in the equation.